Hi guys, I'm going to do this video review with you. You can get a copy of the paper in the Google Classroom where you're watching this video. Okay, so the first question is what is the IQR and how do you find it? So the IQR is the measure between Q1 and Q3. So to find it, you take Q3 and you subtract Q1, and that gives you the IQR. So I'm going to show you using this data listed right here. So the first thing you would do is you would type your data into your graphing calculator. So you hit stat, enter, type your list. On a test or a quiz or something being graded, you definitely want to double check your typing. So I would go back and check to make sure I typed my list correctly. Then you want to hit stat, you arrow over once to calc, and you're choosing one var stats. One var stats means one variable statistics, meaning that you basically entered one list. You're going to hit enter a few times, and that's going to bring you to calculate. You have to know what each of these things mean. You can't bring a little cheat sheet to the test. You have to actually know how to use the calculator and what things mean. So the X with the bar is the mean. And then you have summation X squared, sample standard deviation, population standard deviation, N is the number of data points that you entered. And then you have your 5-number summary. Your 5-number summary gives you the 5 things you need to make a box plot. It also will allow you to calculate the IQR and to calculate the range. So I'm going to take the 28 from the Q3, and I'm going to take the 8 from the Q1, and I'm going to subtract. So that gives me 28 minus 8, which equals 20. Now, the IQR will have whatever units of measure the data had. So like if that data was about ounces, then the IQR would be 20 ounces. Question number 2. When do you use the mean for the best measure of center? Well, you normally would use the mean unless the data is skewed or contains an outlier. So you use the mean for everything except when data is skewed or you have an outlier. So what I like to say is that, the mean is where we want to go. The mean is the average. We use that all the time in school. And that's really what people look for. But that mean is sensitive to any type of skewing or outliers. So when that happens, then what happens is the mean changes and it doesn't truly represent what's going on. So if that was the case, if the data is skewed or there is an outlier, it would be better to choose the median to represent the data. Okay, question 3, how do you read a box plot? So you're looking for the 5 numbers. So this would be the min, this would be the max, and this would be the median. Then this would be Q1, and this would be Q3. Remember, the median is the same as Q2, okay, quartile 2. All right, so if the question says what is the median, 36, 37, 38 would be the median. The median is 38. If they wanted to know the IQR, I would find Q3, I would find Q1, and I would subtract, and that would be the IQR. Okay. How do you find standard deviation and what is the normal range? Well, we're going to look at some data. So basically, there's a very complicated formula for standard deviation. So we're only going to use the calculator. We're also only using samples. So the sample standard deviation is the SX on the calculator. So if I look at my calculator, the SX is 9.7, and I'm rounding to the nearest tenth. The question would have to tell you how you're allowed to round. So I'm going to use 9.7. Okay. Now, to find the normal range is that middle 68%. So you want to take the mean, which I have to find. That would round to 8.1. Okay. So you're going to take the mean, and that's 18.1. Let me just double check because I said 8. Okay, 18.1. And you're going to add the 9.7, and you're going to subtract the 9.7. Okay, you add it and you subtract it. So that gives you the interval that is one standard deviation away from the mean. And that's what we call the normal range. So it's from 8.4 to 27.8. And again, that represents approximately, not exactly, approximately 68% of the data. Okay? 68% of the data is within one standard deviation of the mean. We were using the word typical. That's a good word to use. All right, what makes a good statistical question? Well, a good statistical question would definitely have varied answers. Okay, it would also be of interest. You got to be careful when you say of interest because what interests me might not interest you, but it would have to be something somebody like wants to research. So like a good statistical question might be like, what is the speed of cars going past the school? So like there's a thing called the school zone and you have to go slower because it's safer. And so maybe I want to find out like what's the average speed of people driving. So not everybody's going to drive the same speed. So that's a good statistical question because I'm going to get lots of different answers. Okay. What does correlation coefficient tells us? Okay, correlation coefficient, that's the R, and it tells us the strength and direction. Two things. Okay, so strength. So 0.72, that's fairly strong, okay? And then it's a positive, so that means that it's going to be going up. So we would say positive strong, okay? Now, the sign of the correlation coefficient should always match the slope of the line best fit. So they would match. So the R is positive, the slope is positive, okay? What is a residual plot? That's a good question. So what happens is when you draw this line best fit, the points have a distance away from the line. So you measure the distance a data point is away from the line best fit. And that is called the residual. It's the difference between the exact answer, the actual answer, and the predicted answer. It's the distance between them. And you can be higher than it or you can be lower than it. So all these points below have a negative residual. So then you take all those numbers and you plot them. And what we're looking for is there to not be a pattern. So like this is good. You want a residual plot to be random. So if the residual plot is random, which this one is, then you know that linear regression is a good fit. Linear regression is a good fit. Okay? So a residual plot shows you the distance a data point is away from the line best fit. You analyze this and you're hoping that there is no pattern. If there is no pattern, then linear regression is the best regression for it. Okay, what is a linear regression equation? It's basically the line best fit or the predicted line. Okay, so like I gather this data and then I want to see if I can write an equation for this. So I'm going to go back to my calculator. And this is just going to take me a minute because I have to enter this data. So I go stat enter. I'm going to go above and hit clear, enter. Okay, so I'm entering this data. 1, enter. 5, enter. 3, enter. 2, enter. 1, enter. 7, enter. 4, enter. 3, enter. 2, enter. 3, enter. All right, I'm going to double check that in a minute because you have to double check that. 225, 30, 175, 175 again, 195, 20, 102, 156, 195. I really think the hardest part of this is the typing. 128. All right, so I'm going to double check that I typed correctly, and I'm really hoping I did. Okay, so 1 and 225. Remember, these are ordered pairs. 5 and 30, 3 and 175, 2 and 175, 1 and 195, 7 and 20, 4 and 102, looking good. 3, 156, 2, 195, 3. Okay, great. Okay, so I entered my data correctly. So then I hit Stat, Calc, Linear Regression. Okay, you want to make sure your X list is where you typed your data, your Y list is where you typed your data. You can store the regression equation if you want because you're going to look at the graph. I'm not going to look at the graph. I'm just going to calculate it. Okay, so that's the equation, and you would probably round to the nearest tenth, but make sure you read what it says. So the equation is y equals negative 35.9x plus 251.3. Okay, now I do not have my correlation coefficient coming up, so I'm going to turn my diagnostics on to show you that. All right, that is under catalog, so it's second catalog. And I'm going to turn my diagnostics on. Oh no. Oh no, 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 come on. There it is, diagnostics on. All right, that's under catalog. So stat, calc, linear regression. I'm just doing it again. Okay, so that's my R. Now, you always want to make sure this is the slope, negative 35.86. You always want to make sure that the signs match. A negative R is showing you a negative slope as well. Okay? That's a very strong correlation. That's a good one. Really good. Okay. So it's linear regression on the calculator. Okay. And it's a line best fit. They call it a few things, but we're going to go with line best fit. Line best fit, prediction line, least squares line. They call it a bunch of things. And in this case, it's y equals negative 35.9x adding 251.3. And again, I rounded. On a test, questions always tell you which way to round. Okay, how do you read a two-way table? All right, so you have columns. Columns go down, and you have rows. Rows go across. So you're always looking for a frequency. So for example, I'm going to circle the 13. What that 13 means is that there are 13 freshmen who have cats. 13 freshmen who have cats. Okay? What this one means in purple is there are 16 sophomores who have dogs. 16 sophomores who have dogs. Okay? It's a two-way table, and it's basically giving you columns of information and rows of information. So if I said, how many sophomores are there? That's 25 sophomores. What is that as a frequency or a relative frequency? Sorry, would be 25 out of 50, or 50% of the people are sophomores. Okay, just make sure you know how to read it. And there's so many things on YouTube. Okay, speaking about YouTube, I would watch the video on making a histogram. I posted it in the Google Classroom on May 18th. The making of the histogram is going to be on the take-home part of the test. So you can actually kind of do it as you're watching a video and check it. All right, have a great day, happy studying, and best of luck on your test. But you don't need luck because you have a graphing calculator.